Right. So if anyone who was not there yesterday and who has joined today only, so we will have a quick review, a refresher of what we have done yesterday. Okay. So we talked about yesterday, the entire session was about SQL, where we have talked about what is SQL, that is structured query language, which we use to interact with the RDBMS. Then what is SQL? Why SQL? We have talked about the basic structure of SQL, the database, the tables, rows, and the columns. We have talked about. We have seen the SQL process. We have talked about the introduction. We have seen the SQL environment, that is the editor, results, messages, and the explorer. We have seen the various categories of SQL, that is DDL, DML, DQL, and DCL. We have seen how to create a database, then how to create a table, inserting the data into the table, selecting the or retrieving the data from the table using the select command. We have talked about the various data types in SQL, and there was one small assignment. Then we have seen how to install SQL. We have seen few clauses which are used to selectively retrieve the data from the table, like where and the like clause, where, like, top clause. And then we have talked about the update statement, which is used to make the changes to the data, update, delete, alter. And then we have talked about a drop statement. Truncate, we talked about the truncate command, right, which is used to remove all the records from the table. We have seen the various SQL operators, arithmetic, comparison, logical, and other operators. And this was the second assignment. We have then talked about the normalization. So we have talked about what is normalization. So normalization is a set of rules. Normalization is a set of rules, guidelines, or a statement that we follow to maintain and manipulate the data more effectively into the RDBMS. The two major reasons behind normalization is eliminating data redundancy and ensuring data dependencies make sense, which we have talked about yesterday. And the three normalization forms: first normalization, second normalization, and third normalization, we have talked about in our previous session. And today we need to proceed on with the constraints. Okay, so I think I have to be a bit faster today, right, so that I can give you the maximum value. Okay, so the topic which we need to proceed on from today is the constraints. And somebody asked me the agenda for today. So today we will be talking about managing the data. Like as of now, yesterday we have seen how to create the structure. Now by implementing the constraint, we will be making the structure more powerful. We will be giving the power to the structure. Okay, we will be talking about constraints. We will be talking about few more clauses. Yesterday somebody was highlighting having, order by, group by. We will be talking about these clauses over here. Then we will be talking about right, joins, how to retrieve the data from the multiple tables we will be talking about. And then we will be talking about SQL views. We will be talking about views, functions. So I will try to cover maximum which I can do in this limited time. Okay, so without wasting of any time, I will quickly start with the constraints. Now, what is constraints? Can you give me one small word? What is constraint? Just put it in the chat box quickly, please. Can you give me quickly, please, what do you mean by constraints? Sorry, not constraint, normalization. Rules, absolutely correct. So normalization are the rules. Now, what is constraints? Constraints are also the set of rules. Now here is one confusion. I have given you the same definition for two different things, which is normalization is also a set of rules and constraint is also a set of rules. Then what is the difference between the two? So if you remember yesterday, I have given you an example that we have compared normalization with traffic rules. Now, what is the biggest fear we have if we break the if we break the traffic rules? The first thing which comes into our mind, if we break any traffic rules, that is fine, challan. And who imposes that challan? the traffic police. So if normalization is the traffic rules, then constraints are the traffic police. Normalization says this should happen. Who will make it happen? Constraints will make it happen. Okay, so we have various constraints like primary key, unique, not null, default, check, and foreign key. So we will be talking about each of this one by one. So let us do it practically. And we have created use web2 is the one which we created yesterday. So I will create a table over here. Okay, suppose. Let's fix this. So I have created an employee table over here. Let me try to insert the data into this table. Insert into EMP. Here it goes. The record has been inserted. Let us try to see the record which we have inserted over here. So this is the record which we have inserted. Now, what is the challenge we can see in this record? What is the challenge over here? The challenge is we have a record of an employee who does not have a name and which is not possible. So ideally, this should not happen. Your structure should be powerful enough to store only the valid data. We cannot have an employee without a name. So here comes the constraint. So the first constraint which we will be using over here is the not null constraint. So we will make it as not null. Any constraint can be implemented while creation of table. Increase the font size. Okay. Is it fine now? Yeah, thank you. Okay. So let us, the constraint can be implemented either while creation of table or post creation of the table. So let me implement the constraint over here. But before implementing a constraint, there should not be any data which is violating the constraint. Now, as I already have a name, which is not with a blank name over here, I will not be able to implement the not null constraint. So first of all, I have to either delete this record or I have to add the name. So as of now, I'm just adding the name over here. So I will say update emp set name is equal to. Now, as there is only one record, I haven't used the where clause. Now, I will try to implement the constraint, that is alter table name, sorry, alter table name command completed successfully. Right, so the constraint has been implemented, and let me try to insert one more record over here. Now let's see. Now I am getting an error over here. I'm not getting the, I'm getting an error over here. Why? Because I have not inserted the name. So now it will not accept. I have to insert the name. I will say name and I will say one row. So now your structure will not accept any record without the name. Clear? And if you wanted to implement it while creation of the table, you can simply write over here not null. Whichever way you feel convenient, you can go ahead. Yes, that is what I have told you. This is how you can do it. Right. So this was the not null constraint. The next we have a default constraint. Now, what is default? Default means something which computer do on its own. So computer do on its own. Now, assuming that most of the employees in my company are from Delhi. So I don't want to insert the value for the city as Delhi. I am saying that if I do not specify any value, the value should be by default taken as Delhi. And if I enter a value, the respective value should be taken. Okay. So I will say, so for which we have to implement the default constraint. So alter table name. This is the syntax. Add constraint. Now constraint means a rule. So you have to name this rule. Let's take R1. Alter table name, add constraint name. Which constraint we are implementing? Default. What is the default value? Delhi. For which field? Default Delhi for city. Command completed successfully. Now let us try to insert a record over here. Let's execute this. Command completed successfully. Now, if you notice, I have not specified the value for the city. Let us see. It is automatically coming up as Delhi. Okay, it is automatically coming up as Delhi. And let us try to insert another record. The record has been inserted, let us say. So if you are putting a value, the respective value has been taken. If you are not, by default, it will give you this. Okay. And if you wanted to implement this constraint while creation of the table, you just have to write default delete. So this was the default constraint. Then we have the unique constraint. Now, for an example, you want that no two employees should have the same phone number. So you can make it as a unique. So again, the same syntax, alter table name, add constraint name. You can give it any name. Let's take it R2. So if you will look, except not null, for all the constraint, the basic command, basic syntax remains same. Alter table name, add constraint name. Right? Which constraint we are implementing? Unique. On which field? Phone. Simple. It's done. Right? Now let's try to insert one more record over here. Now we are getting an error over here. Violation of unique key constraint R2. Okay, because we have entering a duplicate phone number. So let's say, let's try to insert it now. It's done. Right? So you can see your constraint is holding the invalid or inappropriate data. And if you wanted to do it while creation, you can simply write unique over here. Unique. Okay. The next constraint which we have over here is a check constraint. Check is used to impose any condition. Example. Let's say I want that the date of birth of the employee should be less than 1 Jan 2000. So I can say same syntax, alter table name, add constraint name, alter table name, add constraint name. Which constraint we are implementing? Check. So I can say check alter table, table name, add constraint, constraint name. Which constraint we are implementing? Check. What is DOP should be less than 01 hyphen Jan hyphen 2000. Command completed successfully. Now let's try to insert a record over here. Let me see, I'm not able to insert this record. Why? Because the date of birth is not appropriate. The date of birth as per the constraint should be less than 1 Jan 2000. So let me make it as 1998. The record has been inserted, right? And if you wanted to implement this constraint while creation of the table, so you can simply say over here, check DOP. That's it. So this was the check constraint over here. The next constraint we have is a primary key constraint. Now, primary key means field. Primary key is the key that uniquely identifies a record in a table. So there must be some field on the basis of which we can uniquely identify the records in the table. So let me show you over here. If we talk about this table where we have 6 fields, which field we can consider to be the primary key? We can have a duplicate phone number, and a primary key cannot be blank, neither it can be duplicated, right? But we can have the employees with the same date of birth. The phone number, again, it is a possibility that a person, 2% sharing the same phone number, or it is also possible that a person doesn't have a phone number. City, we already see we can have multiple employees from the same city. Address and name could also be the same. So what remaining is the employee ID. So employee ID is one of the field which can never be common. 2 employees can never have a same employee ID. So by this, we can see that this is the best field to be considered as the primary key. So let's create a primary key over here, and the syntax remains the same. Let's see. Alter table, table name, add constraint, whatever name you can want it to give. Let's this time R4, or let's take PKID. Which constraint we are implementing? Primary key. Primary key on which field? EID. Now let's see what happens. I am getting an error message over here. Why? Because primary key cannot be null. But if you see, as per the definition of the table says it is fine if you do not specify the employee ID. According to the table, it is okay if you do not specify the employee ID, but primary key is saying no, it is mandatory to insert the employee ID. So there is a conflict between the two. Okay, so we have to resolve this conflict, and to resolve this conflict, we have to make it as not null. So I will make the employee ID as not null. So I will say alter table, table name, alter column ID char 5 not null. So I have specified it as not null, and now I will try to implement the primary key. It has been implemented. Let us try to insert a record over here. See, it says violation of primary key constraint PKID. So why I'm not able to insert this record? Because the employee ID is common, duplicate. So let me change the employee ID. Here it goes. It's done, right? So this is how we can create a primary key, and if you wanted to do it while creation of the table, there are two ways. Either at the end, you can write it like this, or you can also mention over here primary key. Whichever way you want, you can go ahead with that. Phone number is also unique, but yes, absolutely. Everyone said employee ID. Phone number is also unique, but we have not considered the phone number over here because there is a possibility, although it is less probable, but possible that a person doesn't have a phone, right? Or there is a possibility that I do not have a phone and I have shared my phone number of my friend who is also working in the same company as my corresponding number, as my contact number. Okay, so there is a possibility of duplicate as well. But in any case, employee ID can never be duplicate. I hope it's clear. The next constraint we have is the foreign key. Now, foreign key is used to relate the two tables. Foreign key is used to relate the two tables, and for which, let me quickly create another table over here. Create table. Sorry. So we have created a table. Let me try to insert a record into this table. So the record has been inserted over here. Here it is. Now, just look at this record. And do you feel there is any challenge with this record? Anything which you feel is incorrect over here? Yes, we can add multiple constraints on the same field. Now, what do you see? Any challenge? You can use your chat box. Okay. So the problem is if you say select start from EMP over here, select start from employee ID can be same, can be add to, okay. Can't be same. Employee ID cannot be same. Okay. Now see over here. We have the employee ID 1 to employee ID 7, but in the salary table, we are storing the details of the employee number 10. Is it possible? How can we get this, give the salary to employee who does not exist? According to my structure, T0010 does not exist. So that means I have inserted a wrong record. Why it has happened? Because my two tables are not related. So now I have to create a relationship between the two tables, and that can be done with the help of constraints. So we have to make a relationship with the help of foreign key. So let's create a foreign key over here. So same alter table, alter table, table name, emp underscore cell, add constraint, the name of the constraint, you can give it anything, R1, R2, ABC, XY. I will say FKID. Which constraint we are implementing? Foreign key. Foreign key. On which field? EID. Linking it to which table? References, EMP. And which field? EID. Done. Now, the alter table statement conflicted with the foreign key constraint. Why? Now, why I am getting this? Because I currently have an invalid record. So first of all, I have to make the changes to this record. So either I delete the record or I make changes. So let me make the changes to update. Update EMP underscore cell set EID is equal to E0001. Done. Now try to implement the constraint. Command completed successfully. Now let's try to insert another record over here. Now I will not be able to insert this record based because this corresponding employee ID does not exist in the employee table. Let's make it as 002. One record affected. No, sorry, from salary. So corresponding record has been added. So this is how we have related the two tables. So now you can say that you have make your structure more powerful. Now your structure will not accept invalid data. We can connect two tables with employee ID fields. Yes, why not? Of course. Right. There can be only one primary key in a table, but there could be multiple foreign keys. A table can have only one primary key, but can have multiple foreign keys. Right? So let's have a quick review on this, on the constraint which we have did. We have talked about not null. Why do we use not null? To ensure uniqueness of the field. Sorry, to make this entry to the field mandatory. Default gives the default value. Unique, ensure uniqueness of the field. Check, used to specify the condition on a field. Primary key ensures uniqueness of the field. Foreign key used to relate the two tables. Now, if you have noticed, I have given you the same definition for two things: primary key and unique. Unique ensure uniqueness and primary key also uniqueness. Then what is the difference between primary key and unique? And this is a good interview question. So the difference is primary key does not allow null values. However, unique does, but only once. If you have a unique field, you can have only one null value in that respective field. But in case of primary key, you cannot have null values. Moreover, we can have only one primary key in a table, but we can have multiple unique fields. Okay, so this is an important question. Please do remember this. Right, absolutely correct. And here is the assignment. So you have to implement these constraints on the tables which you have created in the previous assignment, right? So same, all these assignments needs to be implemented. I'm not going deeper into this assignment. You can just go through it. It's very simple. Like you have to create primary key, not null. You have to use check over here. So you can do it at your end. let me proceed on with the next topic. And the next topic which comes up over here, absolutely correct, Mayuri. It's foreign key should be the common field between the two tables, and it will be more appropriate if we say not the common, but the comparable field is the good word. It is not necessary that the name of the field should be same, but the data which it contains should be comparable. Okay, right. So now we talk about few more clauses over here, and let's see. The first clause is between, which we have covered yesterday, which is used for range. Example, I want to get the details of the employees whose salary is between 200 to 300,000. So I'm giving a range over here where we can use between. We have talked about it yesterday. In is used for list, right? Supposingly, I want the details of the employees from HR, IT, and admin team. So I'm creating a list, HR, IT, admin. So that is in. Then we have like, we talked about in detail about this like yesterday. That is, like is used to create a pattern, and like has given us two operators, which is underscore and percentage, where underscore represents a single character and percentage represents a series of or any number of characters, I should say. Okay, like I want to get the list of all the employees who are from Dwarka. So if the address contains the word Dwarka, I want to fetch the details. So this can be done with the help of like operator. Then we have the count clause. Now let's see, this is the new one which we haven't done yesterday. So count is used to fetch the data. So to fetch the number of records or number of values within the field. So if I will say select and to give you these examples, let me use another database. So I'm saying in the employee table, I have 133 records. So count is used to count the number of records. When I'm saying count star, if I will say count name, then also I'm getting the 133 record, because in every record we have a name. So that's why the value is coming to be the same. Then we have distinct clause, which gives the unique values of a particular field. Now, supposingly, I wanted to know that I have the employees from which all cities in my company. So I can say select distinct select distinct say city from EMP. So you can see I have the employees from these cities. I have the employees from these cities in my company. So there's 7 cities from which I have the employees in the company. Okay. So this is the distinct clause. Next we have is the order by. Important. Order by is used to arrange the data. For an example, if I say select start from EMP, where department is equal to HR. This is an example which we have in EMP underscore cell, sorry. So I'm getting the list of the HR team members. Now I wanted to get it sorted on the basis of the salary. So I can say order by. Sorting means arranging in an ascending or a descending manner. Order by salary. Order by salary. So you can see it has been arranged according to the salary in a ascending order. If you want to make it descending, you can say descending, that is largest to the smallest, right? So this is the order by clause. Then we have group by clause. Group by is used to create the group. Now, supposingly you wanted to find out the total number of employees in each department. So you can say select department, comma, count of, let's take EID from EMP underscore cell group by department. So it is giving you the team members in each team. Admin team has 10 members, HR has 9, IT has 6, and so on. And as you see, there is no label appearing over here. And if you wanted to give a label over here, you can say as size. And if you wanted to get it arranged, so you can also say order by count of EID. Let's take descending. Here it goes. Right? So I'm getting the team size over here. And right now, suppose over here. So this is what we are getting over here, and group by department. Now, supposingly I want to see the list of only those departments where the team size is less than 10, where of employees is less than 10. So we can say having count of EID less than 10. Let us see. Here is goes. And if you want, can use order also over here like this. It will not work if you will not use group by over here, because until and unless you create a group, how can you perform an operation on a group? Right? So this is here you have to use the group by. Right? Another important point which you have to focus over here is having. This is the another clause which I have used, having clause. And again, an important question from the interview point of view, which is the difference between a where and a having. So where is used to specify the condition on the field. However, having is used to specify a condition on a group. So here I'm talking about the team size. That is a group. So I have to put a condition on a group. That is why we have used having over here. Where will not work. That's what I told you, that we cannot use where over here. We have to use having in this case. Okay. So again, these are the important clauses, and in maximum interviews, you get a questions from these clauses. So on the basis of these clauses, here again an assignment over here. So city-wise count of employees arranged in a descending order. You have to find out how many employees are there from each city. Then details of the employees who does not have an account on Yahoo domain. So use the like clause and try to retrieve this. From the salary table, designation wise, total cost and the number of members arranged in a descending order of the total cost. So we have to, I have done it on the basis of the department. Now the total cost. So for total cost, we have to use a function over here. I can add it over here, comma, sum of salary. So sum is a function which we will be just doing after a few minutes. So sum of salary as total cost. Here it is. So it is showing the total cost being distributed on that team, the total salary being distributed in the respective team. Okay. Right. So right. So the next important topic which is coming up over here is the joins. Now, if you having can only be used with group by, absolutely right, Harsha, absolutely correct. And joins. Joins, if you want, you can note down one line. Joins are required when we need to retrieve the data from more than one table. So many a times I have seen that the people are confused when to use the joins. So I have given you a line, and remember this line, I can guarantee you, you can never get confused in joins. So whenever we come across any, in a real-time scenario, whenever we come across any situation that we have to fetch this data, so the people get confused whether should I use join or something else. So the simple answer is check. Check whether you need to retrieve the data from one table or more than one table. If it is one table, no need of join. And if it is more than one table, definitely you have to use the join. So simple, more than one table data retrieval, yes, we have to use the joins. And we have various types of joins over here, like inner, left, right, full, Cartesian, and self join. Okay, so let's talk about these joins. And okay, let me show you something over here. I will say, here it goes. Now, supposingly I have a requirement that I need to display employee ID, name, city, date of joining, department designation, and salary. Now, what is the challenge in this requirement? So the challenge is employee ID, name, city, date of joining is there in the employee table. However, department designation and salary is in the another table. Which means we have to retrieve the data from two tables, and this can be achieved only with the help of joins. So let's try to create a join over here. So I will say select emp.eid, comma, from the employee table I need name, comma, from the employee table I need employee ID name, city, from the employee table I need date of joining, from the employee salary table I need department, from the employee salary table I need designation, from the employee salary table I need salary. From table 1 employee, from employee join, I'm using inner join over here, join the second table on table emp.eid equals emp underscore cell.eid. Let me first execute it and see I am getting what I was expecting for. So in the total output, you can see I'm getting 80 records over here. Now, first of all, let's try to understand the query which I have written over here. So it says select emp.eid, emp.name, emp.city, employee salary.department, employee salary.salary, and so on. So one different point which you can notice over here is in the previous example, or I should say till now we have not used the name of the table along with the field, but here we are also using the name of the table. We are also using the name of the table over here. Why? Because just to make SQL more clear that these ID as the employee ID needs to be taken from the employee table. Name needs to be taken from this particular table. As we have multiple tables, so we are specifying that bring this data from this particular table so that it becomes more easier for SQL. Right? So I have given all the field list which needs to be displayed from the first table, join the second table. Now I have used the inner join. I could have used inner, left, right, full, any type of join can be used over here, where inner join gives you the common records between the two tables. Okay, inner join gives you the common records between the two tables. So you can see in the output, we are getting 80 records. So these are the common records. If you will see in the employee table, in the employee table, we have 133 records, and in the salary table, we have 80 records. And as the output of the join, we are getting 80 records. Okay. Why? Because these 80 are the common ones which exist in both the table. On. So that is inner join. Inner join the second table, employee salary. On employee.employee ID is equal to employee salary.employee ID. So whenever you are whenever you are joining the two tables, it is mandatory that you need to have at least one common field. We need to have at least one common field. This is the mandatory requirement for creating a join. Then only we will be able to create a join. Okay. From employee inner join employee salary. Clear? On employee.employee ID is equal to employee salary.employee ID. So that is how it has get the data from two different tables. Now, if we want, let me try to bring this query or make this query more simpler for you. What if null values is there and it will return or not? Which null values you are referring to? Can we use star instead of the field names? Okay, so I think here you will get an answer of that. Okay, so let us see. Okay, so now let us see another thing over here, and I will try to make this thing more simpler. And okay, so somebody has pointed out a question, so I will try to answer that after some time. First of all, let me give you this. I'm trying to make this query more simpler. Select emp.eid, name, city, date of joining, department, designation, salary from emp inner join emp underscore cell on emp.eid equals emp underscore cell.eid. And I'm getting the same output, same 80 records are being displayed over here. Okay. Now, can anybody highlight what is the difference between the two queries? Can anybody highlight? Just use your chat box. Absolutely correct that the table names has not been mentioned over here. In the first query, I am specifying the name of the table, but in the second query, I am not specifying the name of the tables. So it is not mandatory to specify the name of the tables because SQL is smart enough to understand that if the name is there in the employee table, obviously it will pick the name from the employee table. And if the department is there in the salary table, it will take it from the salary table only, right? However, I have just given the name of the table with the employee ID. Why? Because employee ID exists in both the table, that is the employee and the employee salary. So in this case, we have to clearly specify that the employee ID needs to be picked from which particular table. Okay. So if I do not do this and see what happens. I'm getting an ID, ambiguous column name. That means SQL has confused from where should I take this. So I will specify EMP. Okay. And I'm writing this again. So this is the question which somebody asked. So I have put in the star, which means the thing's very simpler. I want all the columns from both the tables. So that is what I'm getting over. Okay. No table name and second table. If a two tables have the same column name, then you have to specify the name of the table along with the column, which will clarify SQL that this column needs to be picked up from which particular table, right? So this was an example of inner join. Let's take another example, which we have a left join. Left join. As the name says, left join means all the records from the left table and matching records from the right table. Now, how we will come to know which is left and which is the right table? So the table which is appearing before the word join is left and after the word join is right. So if I say, let me execute this and see, I'm getting 133 records. Let's scroll. So you will see not of null values. Right? So we have more employees in the employee table and the lesser employees in the salary table. So the records which are not available in the salary table, they are appearing as null. Okay. So this is the left join. Let us take a right join over here. Here also I'm getting the 80 records. But what does right join means? Right join means all from the right table and matching from the left table. All from right and matching from left. But in this example, you will see still I am getting the 80 records over here because I do not have any such record which is there in the salary table and not in the employee table because these two tables are related. So once I have the employee, then only I will be giving the salary. So that is the right join over here. And we have the fourth type of join that is known as the full join. Full join, as the name says, all the records from both the tables. So you can see I'm getting 133 records, all the records from the employee table and as well as all the records from the salary table. Okay. So these are the four different type of joins. And to remember this, it's very simple. You just remember this image. Sorry. Remember this image over here where inner join common between the two tables, right, all from right, matching from left, left, all from left, matching from right, full, all from both. Okay. Then we also have something known as Cartesian join. Cartesian join also referred to as a cross join. Now, for which I will take another table. I have a table with the name. So I have two tables over here with the name CJ1 and CJ2. In the table CJ1, I have the roll number and name, and in the CJ2, I have the roll number and marks. In the table CJ1, we have the roll number 1, 2, 3, 4, 5. However, in the table CJ2, we have the roll number 1, 2, 3, 10, 11. Now, what does cross join means? No, we don't have to. We just need one common field for the join. Okay. So cross join, it will take all the records of first table and match it with the first record of the second table. Then again, it will take all the records from the first table and match it with the second record of second table. Then again, all the records of first table with third record of second table, and so on. And so on. So let's see, how does it work? So I will say select. And also notice we have the roll number 4 and 5, which is there in the CJ1 and not in CJ2. And there's a roll number 10 level, which is there in CJ2 and not in CJ1. So I will say select CJ1 dot roll number, comma, CJ1 dot name, comma, CJ1 dot marks from CJ1, sorry, not inner, cross join. Cross join CJ2. Cross join CJ2, nothing else. Now see what happens. The CJ2 I have to take over here. So you can see I'm getting 25 records because both the table has 5 records each. So 5 into 5, that is 25 records I'm getting over here, right? So you can see 1, 2, 3, 4, 5, which is all the records from the first table matched with the first marks, that is 90. Then again 1, 2, 3, 4, 5 with the second marks. Then again 1, 2, 3, 4, 5 with the third marks, and so on. Okay. So this is how it is happening over here, and we are getting a cross join. But one important point to be noted in a cross join, that in the cross join, we do not have an on keyword. On CJ1 dot roll number is equal to CJ2 dot roll number. If I try to execute it, I will be getting an error because cross join does not accept on keyword. However, if you use where over here, what output you are getting? You are getting the 3 records, and these are the common records. So again, an important interview question, that is the relationship between the cross and the inner join. So cross join, you can remember this, cross join plus where is equal to inner join. If anywhere in the interview you got this question, this should be the answer. Where should we use cross join? So one example I have shown you that it can be used as an alternative to inner join. Or another example I can say, suppose in a company there are say 10 MIS team members, and all the MIS team members needs to appear for 3 certifications. So how many total certifications has to be done? So all the 10 members with the first certification, then again all the 10 team members for second, and all the 10 team members for the 3. So 10 into 3, that becomes 30. So this could be an example of cross join. Okay, then we have another thing over here that is known as the self join. Now, what is a self join? Now, first of all, very important concept. I will try to explain it in a very short manner, in a very simple manner. I would like to explain the self join. Join means more than one, and self means one. So what could be a self join? First of all, remember, there is nothing known as self join. Okay, and remember this line that there is nothing known as self join. And now I will tell you an example of self join. So let's take an example. Select star from, I have a table with the name as J, and I have one more table. Let us have a look at these two tables. So I have a table with the name as J, and I have a table with the name boss. In the table SJ, I have the employee ID, the name of the employee, and the boss ID, where A being the super boss, so there is no boss of A, B and C, the boss is 1, D, the boss is 2, E and F, the boss is 3, that means C, and G, the boss is 6, that means F. Now, I have a requirement that I need to display the employee ID, name, and the name of the boss. Instead of boss ID, I need the name of the boss. Now this thing become very simple because it's a simple join. So let us write select sj.id, sj.name, sj. Okay, so not sj, boss dot name from sj. Let's take left join. On. Now it is important that which two fields needs to be compared. So I have to compare the boss ID with the boss ID. So on sj dot boss ID equals to boss dot ID. Here it goes. So I'm getting the required details. A, there is no boss. B and C, the boss is A. D, the boss is B. E and F, the boss is C. And G, the boss is F. This is exactly what I was looking forward to. And if you say that the name and name is appearing twice, you can give it a label as boss name. Okay. Now, once again, have a look on these two tables. In the table called SJ, we have the employee ID and the name. Try to understand and focus over here. In the first table, we have the employee ID and the name. Now, is boss of a company also an employee of a company? What do you say? A boss is also an employee of a company? Yes or no? Yes. Yes, obviously the boss is also an employee of the company. So I can say in this table, I have the employee ID and name. And in this table also, I have the employee ID and the name. Now, if we just talk about the first normalization form, it says that there should be no duplicacy of the data. There should be no redundancy of the data. So that means this structure is against the normalization. Okay, this is against the normalization. So if I go as per the normalization, I don't need this table. So now assuming I have only one table, that is SJ, and I wanted to get the same requirement. I need the employee ID name and the boss name. So let's see how can we do that. So Just to make you understand, let's take, I am taking the two copies of the same table, just to make you understand, right? So these are the two copies of the same table. This one, let's name it as S1 and let's name it as S2. So I will say from the S1 take ID, from the S1 take name, and from the S2 take name, from SJ, S1, left join, SJ, S2, that is the second copy. Now I need to compare this field and this field. So I will say on S1 dot boss ID is equal to S2 dot ID. Let's check this. And we are getting the desired result. So I have created, or in other words, just to make you understand, I have shown you the two copies of the table in which I have compared the third column with the first column of the table. From first table, I have taken the third column, that is the boss ID. And from the second table, I have taken the first column, that is the ID. In other words, can I say that I am comparing the third and the first column of the same table? I am comparing the third and the first column of the same table, right? So that means I am comparing a table to itself, and this is known as a self join. When I am comparing a table to itself, this is known as a self join. But a few minutes back, I told you that there is nothing known as self join. So the answer is still I'm saying that there is nothing known as self join, because if you look at my query, which join I have used. If you will look at my query, I have used the left join over here. Okay, so by this, I wanted to highlight that self join does not exist syntactically. It only exists logically or theoretically. It's a logic, it's a concept. Conceptually, there we have a self join, but if we talk about like syntactically, there is nothing known as self join. I hope it is clear. And this is also an important topic regarding interview. See, I'm also highlighting few of the important interview related topics. I will not call it as a question, but the topic. So this was about the self join, and these are, so let me again, as we are running short of time, so I'm just focusing on few of the very important things. So here again, an assignment. So it's a simple assignment based on the joins. So you can just go through it. Right. The next thing which comes up over here is the SQL view. Now, what is a view? View means, simply means, in a layman term, view means to see. Okay, view means to see. So view is a different way of looking at the table. Okay, so, or I will give you a single line definition of the view. If you remember this line, I can guarantee you in your life, you can never get confused in views. Views are the virtual table. If you want, you can note down this line. Views are the virtual table. Okay, now virtual means something which is not real, and table is a collection of rows and columns. So if we combine these two words, virtual table, such a table which do not have any rows and column is known as a virtual table, right? And why do we use views? Why the views are required? So here it goes. So view are kind of virtual tables which allow the user to do the following: structure the data in a way that user or classes of user find natural or intuitive. Restrict access to the data such that the user can see and modify exactly what they need and no more. Summarize the data from the various tables which can be used to generate reports. Okay, so let us see over here. Let's create a view. So right. Now here you can see I'm getting the list of the employee. I have 133 employees over here. Now, which are from the various cities. Now, supposingly there, because of some say, let's take compliance requirement. I want that, let us see, employee from where here it is. So I have 12 employees from Dehradun. Now, what I want that the Dehradun employee should not be able to see the details of the employees from any other city. They should only be able to access the details of Dehradun employees. Okay. So in this case, what can be utilized? We can utilize a view over here. So let's create a view. Create view. Whatever name you wanted to give. Create view name as, and that's it. Let me execute this. Command completed successfully. Now you write a query, select start from LW. Here it goes. So I'm getting the details of the Dehradun employees. Now you can tell the people of the Dehradun, you can tell the employees of the Dehradun that the details of the employees has been stored in the table called DEMP. LW2 DEMP is the name of the table in which the details of the employees has been stored. So like this, they will never be able to access the actual table. They will never come to know that there is some other table because you haven't told them. They will only think that there is only one table, that is DEMP, in which we have the details of the employees. So we have restricted the, or we have enabled the user of the employees of Dehradun to be able to access the details only for the Dehradun employees and nowhere else. Okay. Right. So this becomes a virtual table. Okay. And all the things which you do on a table can be done over here: insert, update, delete. Using this view, you can do each and everything over here. Okay. So this is an explanation of the first point, which says structure our data in a way that user or classes of user find natural or intuitive. So by this, I wanted to say a user can never come to know that whether he is working on a view or he is working on a table, actual table. Okay. Second, restrict the access to the data such that the user can see and modify exactly what they need and nothing more. Now, second example, assuming that the address and date of birth of the employee is the confidential information, and it needs to, and all the employees should not be able, or I should say, selective employees should be able to access this information. Again, view will help us in this case. Create view name as select PID, name, city, phone number, email, DOJ from. Let me execute this. Now you can tell the employees that the name of the table is LW2EMP. So whenever any person writes See, the person is not able to access the address as well as the address and date of birth. So like this, we have restricted some information, or we have made some information hidden from the user. Okay. So that explains the second point clear. Right. So this justifies the second point. Now summarize the data from various tables which can be used to generate the reports. Now this is the most common utility of views. The most common utility of views is this. So, for example, I want to get the salary details of say ops team members, or let's take HR team members. I want to get the salary details of HR team members. So I will say select emp.eid, name, city, date of joining, department, designation, salary, let's claim it as basic, salary into 0.15 as, let's take HRA, salary into 0.09 as EF from EMP inner join EMP underscore cell on EMP.eid equals EMP underscore cell dot EID, where department is equal to HR. Let's execute this. So here I'm getting the salary details of HR team members, and but every time I need this information, I have to write this long query. So I can make it simple with the help of view. So let me say create view. Let's take create view name as, let me execute this command, completed successfully. Now whenever you want to get the salary details of the HR team members, you will say simply select star from salary. Here it goes. So needless to say, which query is simpler? Instead of writing this query again and again, you simply write a small query and you are getting the desired result. So like this, views can be used to generate the reports. So by giving you these examples, I have just tried to explain these 3 points. Okay. Right. So updating a view, we can also do the data manipulation using the views. Great. So we can also do the data manipulation use, that is data manipulation means insert, update, delete can also be done, but under certain conditions, which are the select clause may not contain a distinct keyword. If in your query you have used a distinct keyword and then created a view, then updating using a view is out of the question. The select clause may not contain summary functions, as we have used some count. If we have used something like this, the view updating through the view is not possible. The select clause may not contain set operators. So we have not talked about the set operators, so we can ignore this point. The select clause may not contain order by clause. So we cannot use order by clause in the definition of the view. The from clause cannot contain multiple table, as we have taken an example where we have created a view which is based on the multiple tables. So if you have created a view on the multiple tables, then updating using the view is out of the question. Then the where clause may not contain subqueries. So we have not talked about the subqueries so far. The query may not contain group by or having. So if you have used group by or having in the definition of the view, then updating is out of the question. Calculated column may not be updated. So if you have some calculated columns, there is a probability that that could not be updated. All the not null column from the base table must be included in the view in order for the insert query to function. So as we have taken an example that we have created a view in which we have not taken the address and the date of birth. And if we try to insert the data using that view, so it will only be possible if it will not be possible as the if address and date of birth is a not null field. Okay. If you wanted to drop a view, it's simple. Drop view name. You can drop the view. Let's take drop view. The view has been dropped. Does not exist. Okay. So again, here is a small assignment on the views. So this is the same example which I have taken. So you can use it. Okay, now the next topic which is coming up over here is the SQL function. But before we proceed on with the SQL function, how is it going? How is it going? Can I see some energy in the chat box? Super, good. Okay, lot many people, very few responses. I read fire. Great, great, good. Are you all enjoying? Okay, wonderful. Thank you for the responses. I like that you are enjoying the session. Absolutely, Pulkit, you have to learn a lot in this. See, we have a time constraints over here, so I have to be a bit faster in this. Enjoy while listening. Yes. Yes, Karuna, you have to, this is what we can do it over here. So be attentive, enjoy and this session and listen till the end of the session today, right? So many more important things are in the pipeline. Yes, you will be getting the recording as per promised by the admin team. Okay, and as there are few more important topics which I am trying to cover in this module if the time permits. So I'm doing bit faster over here. Today I'm being bit faster. Okay, so please try to understand this, because otherwise this complete module of SQL takes around 25 hours. So I'm trying to deliver max, which I deliver in 25 hours, in 4 hours to you people. Okay. So obviously I have to increase the speed and bit faster with the lesser of examples. But yes, after completing this or after devoting your 4 hours with me, you have an idea about SQL, and SQL will not be a stranger for you. Okay. So with this, okay, if you wanted to practice on SQL, you don't need to go anywhere else. First of all, if you just complete the assignments which I have given in this module, that will make you confident, right? So first try to do the assignment which I have given, right? So let's talk about SQL functions. Now, what is a function? Function is a pre-written code, pre-written functionality. So if there is a particular piece of code which I am using it over again and again, we can create a function for it. Let me give you a very simple example. In Windows, in Microsoft Office, everywhere we go to PowerPoint, we go to Word, we go to Excel, everywhere we go, we have a functionality of spell check, right? In every tool, we have a functionality of spell check. Now, if you think from the programming perspective, there must be some coding written for it. There must be some coding for it. Okay, but do the coding has been done again and again? No, the coding has been done once, and thus some name is given to that coding. And whenever that functionality is required, we use that name. Okay, so same is the function. So function is a name given to a pre-written code, and there are some inbuilt function in SQLs which are count function, which I have talked about, which gives you the number of records. Then we have this max function. So let me quickly tell you a few of the important functions. I will not be able to cover all, but I will highlight few of the important ones. So I will say select sum of salary from empty underscore cell. So it is giving us the total salary being distributed. And I will also take select count of EID. So the total number of team members is 80, and the total salary being distributed within this team, within this 80 team members is this much. Out of which, if I wanted to see the maximum salary, so I can use the max function over here. So the maximum salary is 520,000. And similarly, if you wanted to see the minimum, you can use the minimum function over here. And the minimum salary is 35,000. If I wanted to see the average salary, so I can say average. So the average salary is 132,000. Okay. Here it is. So max, min, average, sum. Then we have a square root function, which will give you the square root of any number. If I will say select square root of 25, the answer is 5 over here. So I'm getting the square root. Then you have concat function over here, which is used to concatenate the two strings. For an example, if you say select concat hello, comma, so you can see there are two separate words, hello and world, but we're using the concat. I have concatenated the two. Right. And if you see there is no space, if you want to incorporate the space, you can put the space over here, and here it goes. Right. So concat, then we have ASCII. ASCII is used to get the ASCII value of a particular character. ASCII means American Standard Code for Information Interchange. So if you say, let's take select, any character which you see on a keyboard has an ASCII value. So select, oh, I have forgotten ASCII, ASCII of A. So you can see I'm getting the ASCII value of A is 65. Similarly, a reverse of ASCII is char of 65 is A. Okay, char 65. Okay, so then we have a function called char index, which is used to find the position of a character within the string. For an example, if I say select char index, I wanted to find out the character C in the word welcome. So at which position C is occurring within the character welcome? It is a fourth position. So you can say 1, 2, 3, and 4. Then we have a function called select left, which is used to extract the specified number of characters from the left hand side of the string. So if I say left welcome, comma 3, so I'm getting 3 characters from the left hand side of the string. Similarly, we also have right, which is used to extract the specified number of characters from the right hand side of the string. Welcome, comma, port, let's take. So I'm getting come over here. Then we have a function called length, which is used to find the length of the string. So I will say select len of welcome. So there are 7 characters within the word welcome. So ideally, when we use this thing in the real time, in the real time, these functions are used in combination with each other. Okay, so that is how we use it. As of now, I can just give you an idea that what this command do. Then lower converts a string to a lowercase and upper converts the string to uppercase. Few more string functions are substring, which is used to extract the part of the string, substring. See, it will be quite tough to repeat any of this. Square root will give you a simple square root. If you will say select sqrt 25, it will give you the square root of 25, that is 5. As simple as that. Okay. Then we have substring over here. So I will say select substring from the word welcome, starting from the 4th position. I need 3 characters. What should be the output? 4th position, 3 characters. The output is come. 1, 2, 3, 4. From here, 1, 2, 3. That is COM. Substring. Then we have a replace, which will replace a particular character within the string. As you can see an example over here. In India, I want to replace I with K. So wherever the I will occur in the word India, it will be replaced by the character K. Then we have the function called reverse. It will reverse the string. Suppose I will say select reverse India. So India has been written in a reverse manner. Left to right has become right to left. Then we have few of the date functions. So the date functions are, the first is the get date, which is used to return the current date. So I will say select get date. So it is displaying the current date, that is 16th of December 2021, 9:43 p.m. So date along with the time is this is my system date and time. Okay. Then we have date add. If we wanted to add a number to a date, we have a function called date add. So I will say date add. I want to add and days. Right. So what does it says? I have added date part, the number, and the date. So I'm adding date. Date part can be D, M, or YY, where D stands for day, M stands for month, and YY stands for year. So if I wanted to find out what will be the date after 10 days from today, so I have said date add day, comma 10, comma get date. So it is saying after 10 days, the date will be 26th of December. Okay. If you wanted to say month, I wanted to say what will be the date after 2 months from today. So it will be 16th of February 2022. Or if you want to have year, what will be the date after 2 years from today? So it will be 16th of December 2023. So this is date add. Then we have the date difference, which is used to get the difference between the two dates. For an example, let me take this example, select EID, comma, DOJ from EMP. Let us also take the name. So employee ID, name and date of joining we are getting over here. Now I wanted to find out the tenure. That's for an example, Ramesh Gupta is with the company since how many years or days? So I can say comma, date, date diff. I want to find out day. The starting date is date of joining and the ending date is the current date. And if you want, you can give a label over here as tenure. So the Ramesh Gupta is with company since 3,563 days. But this days doesn't make a sense to us. So I will make it as, let's see if it makes more sense. So 117 months, but still it doesn't make a sense. So I will take year over here. So now I am getting the number of years. So Ramesh Gupta is with the company since last 9 years. Okay. So this is what we are getting a tenure using a date diff. Then we have day, month, and year function. So which is used to extract the day, month, or year from the date. So for an example, if I say select get date, comma, day from get date, comma, month, comma, year. So here it is. It is the 16th day of the month, 12th month of the year, and the year is 2021. And you can also do the same thing using another function which is known as date part. Date part, b comma get date, date part, month comma get date, and date part, year comma get. Same output you are getting. So either you can use the separate function that is day, month, and year, or you can use date part to extract day, month, and year from the respective date. Then we have a function called convert, which is used to convert a date into a string. So I can say select convert So you can see that the date has been converted over here like 16th of December 2021, 9:48 p.m. So you can see the format of the date has been changed. It has been converted as a string over here, right? Then we have another function called format. So I will say select get date, comma, format, get date, comma, D. So here you can see that the focus is on the day. Day means Thursday. Today is the Thursday. Or let me take it as month and I will take it as year over here and see the difference with the dates you are getting. So when I say day, the focus is on date. Today is Thursday. Then I say the month, the focus is on month, December 16. When I say year, the focus is on year, that is December 2021. Okay. So this is the day, month, and year function. Okay, then we have something known as user defined functions. What are all the concepts, sir? Please share the PPTs after the class. Yes, you will be getting these things. Okay, admin team will be sharing it. What all are the concepts remaining in SQL? Yes, I will tell you about that. The concepts. Let's quickly have a look at the user defined functions also. So SQL also allows you. So I have taken an example of few of the functions which are there in SQL, inbuilt functions, but we can also create our own functions, right? Which are known as user defined functions. We can also create our own functions over here. So if there is a particular code which we are reusing again and again, we can create a function. So let me give you a very simple example to create a function which will give you the sum of two numbers provided. So let us create a function over here. Create function. Let's name it as let me create in your view. Create function, the name of the function, you can give any name you like. @x as int, comma, @y as int. Returns int as begin, where @z as int. No worries, I will explain this what I'm writing. And set @z equal to @x plus @y, then return @z and say end. Command completed successfully. Now let's try to execute it like other functions which I have executed. So I will say select my sum. Let's say 10, 20. So the answer should be 30 over here and see what happens. Now I am getting an error. Why? That my sum is not recognized as a built-in function name. SQL cannot recognize this function. Why? Because this is not the inbuilt function. SQL is trying to search for this function in its default environment with the other functions, but it is not available over there. So what can we do? We have to say over here dbo dot. And now let's execute it and see we are getting the result. So where DBO stands for database object. Where DBO stands for database object. So which means my sum is the date object which has been declared within the current database, and the name of the database is web2. Okay. And now let me quickly explain the function which I have written. So create function is the command. Then my sum is the name I have given to my command or my function. Within the parenthesis, I have written @x as int and @y as int. In SQL, when you put @ in front of anything, it becomes a variable which holds some value. And these two variables are of integer time. Now, if I explain this complete line, I am asking SQL to create a function which will take two integer values as a parameter. Okay. Then returns int. Always remember, function will always return a value. And a function can, these are known as parameters or the arguments. The value which function is taking is known as parameter or the argument. So function can take any number of arguments, but will return only a single value. It can never return more than one value. Right? So create function mysum @x and y, x as int, y as int, return int. So these two line means I am asking SQL to create a function with the name mysum, which will take two integer value as a parameter and return an integer value as a result. Now as begin. Now, between begin and end is the entire functionality of the function, where we have said declare at the rate z as int. So declare is a keyword to declare a or to create a variable. So I'm asking SQL to create a variable with the name z of integer type. Now set is a keyword to assign a value to a variable. So I'm saying set at the rate z is equal to at the rate x plus at the rate y. So the sum of x and y will be assigned to the variable z. Then return. By specifying return, we are asking SQL to return the value of the variable z as an output. Okay, so that is how the function is working. So it's a very, very simple example. You can have any logic and you can put it into the function so that if it is required again and again, you do not have to do the entire step. You just have to use the function to get that functionality. Okay, is that clear? Okay, transaction part, I would love to, but I think the time will not permit me to explain the transaction part. Who was asking for the transaction? Chandan. Yes, Chandan, I would love to explain the transaction part, but I won't be able to because we have limited time remaining with us. So let me quickly take you through that what all few other points. I will give a quick review of what are the things which we are not able to cover in this session. So let me go back over here. And we have talked about the user-defined functions over here. Again, few assignments. Now there is another concept which is important, that is subquery. And in this, we have an example of we write a query within another query, right? That is known as a subquery. Okay. For an example, if I say, let me give an example. I want to get the employee ID and name of HR team members. I want to get the name, or simply say, I want to get the name of HR team members. How can I get a name? Because the name is there in the employee table and the department is there in the salary table. So here you might be thinking, oh, I'm talking about two tables. That means I am talking about joins. But not, my dear, we are not talking about joins over here, because I am not saying that I have to retrieve the data. Focus what I have to retrieve. I am saying I want to see the names. I only want to see the names. So there is a situation where we have to use the subquery, something like this. Select name from EMP, where EID in select EID from no drawings, EID from EMP underscore cell, where department is equal to HR. And here it goes. Oh, are you getting bored? You are doing some drawings. Please don't do that. Oh, so much. Annoyed, huh? Okay, so here you can see this is an example of subquery I have written. So within one query, I am writing another query, and this is the concept of subqueries, right? So this is one of the topic. It is very important topic, and which then this was one of the queries. So multiple examples can this, and then we have something known as stored procedure. Stored procedure, it is a name given to a code. Name given to a code is known as a stored procedure. Instead of writing the entire code over again and again, we can use this name to run that respective code. So that is known as a stored procedure. Now, okay. Then we have something known as triggers over here, which we can, in the triggers are a special kind of stored procedure that get automatically executed. So you can say triggers are used when we need to do some automation sort of thing. And these are also a type of stored procedures over here. And as far as the transactions is concerned, in the transaction, in the trigger, you will get an example of transaction. Let me see. Transaction, as you have highlighted, transaction is a unit of work performed against a database, or you can say on the database. In transaction, practically we have only three things: commit, rollback, and save point. Where commit means to save, rollback means to undo, and save point means to create a flag. And these transactions are considered to be acidic in nature, which means the transaction has acid property, that is atomicity, consistency, isolation, and durability. All right, so transaction is also an important topic, and I can give you a simplest example of a transaction: the monetary transactions. You are transferring some amount from your account to your friend's account. What is this? It is a transaction. And we are saying it is a unit of work. Unit of work means there are multiple steps within the transactions. So when you are transferring your amount to some amount from your account to your friend's account, what is happening? The amount from your account is being deducted, and the amount to your friend's account being added. So there are two steps. Okay. So this is known as transactions. Right. So it is also an important topic, but as the time is restricted, so we have tried to cover the max which we can over here. And so with this, we have to pause for the day. And so I have tried to answer as many questions as I can. So this is Rajiv Garg. Thank you very much for attending this module with me. And I wish you a great career ahead. Bye-bye. Take care.